yesterday we were talking about what makes a function a function, what makes a relation a function. I got chat here. Okay, gotcha. What makes a relation a function? And remember, we said that for each element in the domain, it's mapped to 1 in the range, right? Now, it could be that you have two different things in the domain mapped to the same one in the range. That's fine. But each element in the domain should only be mapped to 1 item in the range, or each value in the domain should only be mapped to 1 value in the range. And that's what makes our relation a function. We talked about how graphically that relates to the, we can use the vertical line test. Because if we look at a graph, and if you have something like, let's say this, you have a vertical line test, fails it because it intersects right there and there, because that value is basically like 2, 3 and 2, -3. So for that domain value of 2, you have 2 different values in the range that's mapped to 3 and -3. Okay, and so that's what would make it not a function. It's just a relation at that point. Any questions on that? All right, so erase all that. How do we determine if we're given just the equation x squared plus y squared is equal to 1? How do we figure out if that is a function or not? It is a relation, right? You put in an x value, you get a y value. But how do we know, or you put in a y value, you get an x value? How do we know, or how can we figure out if it's a function? What do y'all think? Think about what makes it a function. Basically, you have your relation, right? Let's call it an R. And for your relation, you have an input. You put something in there, that's your domain. And then you have the output. And what makes it a function, if you remember, is if I put in some value here, or does whatever it does, and I get the output, you know, is 1 value, right? You put something in for x, you only get 1 y. All right? So what we're going to do with the equation is see if that's true. And the way that we do that is we'll take that equation and we'll solve it for y. So we'll take that equation and we'll solve it for y, and then we'll make the decision, right? Because then we'll have it set up so we put in an x and we get a y out. Well, yeah, we get a y out. So if we take this one, I'm not to write it again because I wrote again under it. I always do that. We have x squared plus y squared is equal to 1. If you want to solve that for y, what do we need to do first? Do what? That's if you're trying to find the y-intercept. That'll work. But what if you just want to get y defined in terms of x? You just want to get y by itself. What do you think you would do first? Subtract the x squared. Let's move the x squared to the other side. Yes. So we'd have like y squared is equal to, let's write it as 1 minus x squared. It really doesn't matter. I should have left some room there. I'm just going to rewrite it. All right, so if I have y squared is equal to 1 minus x squared, how do I solve for y now? Right now it's solved for y squared. what do we do? Now it's in what? Section 1.4? How do we solve for that? No, that wasn't section. That was like 1.2. Well, if you have the variable squared on one side and you have some other term on the other side, take the square root of both sides. The only thing is the side that's opposite the variable you're solving for can be plus or minus. And so what we end up with is y is equal to plus or minus the square root of 1 minus x squared. You can't break up a square root on addition or subtraction, so we have to leave that as is. That does factor to be 1 plus x, 1 minus x, but that is no use to us here because it's not a term that's squared. So that's just what it is. And so think about it. Is this defined so that way if you put in an x value, you get one y value? Why not? It's because the plus and minus, right? If I put in an x value of, what would be a good one? That's not many good ones. Oh, let's just say whatever. So let's say I put an x value of 2, right? So x equals 2. Then y is going to equal plus or minus the square root of 1 minus 2 squared. So y is going to equal plus or minus the square root of 1 minus 4. So y is going to equal plus or minus the square root. That's actually a really bad one because it's negative 3. So that's not even in the domain. So let's try again. Oh, I got an easy one. Do 0. All right, so I have y is equal to plus or minus the square root of 1 minus 0 squared. Y is equal to plus or minus the square root of 1 minus 0, so we're just 1. So y is equal plus or minus 1, because the square root of 1 is just 1. So that gives us that 0 is mapped to 1, and it's also mapped to negative. So, and when you solve for y, if you get something that's going to give you 2 different values for the x's you plug in, it doesn't have to be every x, which we'll look at in a second. But if there's some values of x you plug in that gives you multiple values for y, it's not a function. But this right here is not a function. Any questions on that? Now, is there a value for x I could put in here that would result in a single value of y? What do you think? What if x was 1? And then y is equal to plus or minus the square root of 1 minus 1 squared. Y equals equal to plus or minus the square root of 1 minus 1. So y equals plus or minus the square root of 0. So y equals plus or minus 0, which is 0. So this relation has the order pair of 1 comma 0. But if it fails for any point, it's not a function. Remember the graph we did with the, well, I don't know what you call it, the graphic we did with the bands and the genres, the musicians and the genres. If it fails for 1, it's not a function. So there may be somewhere it is, okay, but as long as you can find 1, it's not a function. Any questions on that? The other thing you can do, if you just can't figure this out for one of them, is to graph it, right? Graph it. If it fails the vertical line test, it's not a function. That's the other way that you can do it. Any questions on that? this. Oh, okay. So to find the value of the function, all you gotta do is, okay, I didn't realize that function. If you want to find, if you have a function f, you want to find what f of 1 is, what are you going to do? You just take that 1 and you plug it in to the function. Now what's interesting here is that f of 1 and f of negative 1 both equal 1 because it's x squared, but that's fine. Remember, they can map to the same value, you just can't have one value mapped to 2. If we look at the second one here, b, you put in a negative 2 into f, it's 1 over x, so it's going to be negative 1/2. You put in a negative 1, it's 1 over negative 1, that's going to be negative 1. You put in a 4, that's 1 over 4, so it's going to be 1/4. Now, we can work out some of these, like let's say you had a function, let's call it g of x, and it is equal to, let's say 3x to the third minus 1. And let's say you want to find what is g of 0. What are you going to do? You're going to plug in it. You're going to substitute whatever you put here for the x. So this is going to be 3 times 0 to the third minus 1, which is going to, well, I guess I don't have to write it every time. Which is going to equal 0 minus 1, which is equal to negative 1. So g of 0 is equal to negative 1. That means that that function has a mapping from 0 to negative 1. Any questions on that? We could do something a little bit more advanced. We could say, what about g of negative 2? Give me 3 times negative 2 to the third minus 1, which would be 3 times negative 8 minus 1, which would be negative 24 minus 1, which is negative 25. And so you'd have the ordered pair negative 2 from a negative 25. Right? You just plug it in wherever the variable is, and that'll get you what the resulting value is. The y value. You want to think about it in x and y. Now, what if that is my g of x, and I want to know what is g of h? What are we going to do? It's the same thing. Wherever there's an x, I'm going to plug in an h. So this is going to be 3 h to the third minus 1. I mean, you can plug in whatever you want. It doesn't have to say that the function just takes numbers. I mean, we get really abstract and say I want to do g of a triangle. And so it's going to be 3 times the triangle to the third minus 1. Right? Whatever you put there, you're going to plug in where the variable is. All instances of the variable. So, like, let's see. Let's say we have, let's call it, let's go back to f of x. So f of x is equal to 2x squared plus 3x minus 7. And you want to know what is f of, 4 is kind of large, huh? Yeah, whatever, we'll keep it. F of 4. What are we going to do there? We're going to plug in a 4. Everywhere is an x. So it's going to be 2 times 4 squared plus 3 times 4 minus 7. And so what's going to happen there? Well, let's see. It's going to be 2 times 16 plus 12 minus 7. It could be 32 plus 12 minus 7, which will be 44 minus 7 is what, 37. And so you would have the order pair 4 comma 37. If I did all that math right, I think I did. Any questions on that? Here's my question. If that's f of x, what if I want to find f of x plus 1? What am I going to do there? We're going to plug it in. And so it's going to be 2. Oh, I got to hold the laptop. I can't write. It's going to be 2 times x plus 1 squared plus 3 times x plus 1 minus 7. Can we evaluate that some? Yeah. We can do some stuff. X plus 1 squared is the same thing as x plus 1 times x plus 1, right? And so that's going to end up being, if you use like FOIL, whatever you use to expand it, be x squared plus 2x plus 1, right? So this first term would be 2 times x squared plus 2x plus 1. We could take this 3 and distribute it to the x and the 1. So this would be 3x plus 3. And then we still have that minus 7. Don't forget about that at the end. And then now, let's distribute the 2. It's going to go to the x squared. It's going to go to the 2x. It's going to go to the 1. So this would be 2x squared plus 4x plus 2. And we get the plus 3x plus 3 and a minus 7. Any questions on getting there? And now we just combine the like terms. I have no like terms with the x squared, so we would keep that as 2x squared. I don't know why it equals. We got a 4x plus a 3x, so it'll be 7x. And then I got a positive 2 plus 3 is 5, minus 7 is negative 2. So f of x plus 1 is going to be 2x squared plus 7x minus 2. Any questions on that? Nope. So whatever they give you, plug it in, go from there. Let's try another one. We'll keep working with the same function. All right. What if we want to find? Yeah, let's do that. 4 times f of x. What do you think we will do there? It's not as complicated as you might think. It's pretty straightforward. It's just 4 times what f of x is. So this is just going to be 4, excuse me, times 2x squared plus 3x minus 7. And then you just distribute it across. So 4 times the 2x squared give you 8. x squared, 4 times the 3x would be plus 12x, and 4 times the 7, or the negative 7, would be negative 28. And so that's what 4f of x. It's kind of like when we multiply the system of linear equations. Remember we did that? It's a similar thing. That we multiplied both sides. This time we're just multiplying functions. But it distributes amongst it. Any questions on that?
Would you ever have a number for like, so would it ever be like 4f of another number or no?
It could be.
What would you do like that?
So saying like 4 f of 3.
Yeah.
So in that case, it's going to be 4 times f of 3, which would be 2 times 3 squared plus 3 times 3 minus 7, which is going to be what? 4 times 2 times 9 is 18. 9 minus 7, and that's going to be what? 27 minus 7, 20. That'd be 80. Which is what is interesting is if I plug in a 3 into this, I should get the same thing, right? Because this is 4 times f of x, and we did 4 times f of 3. But let's do it real quick. It'd be 8 times 3 squared plus 12 times 3 minus 28. So that'd be 8 times 9, which is what, 72 plus 36 minus 28. 8. So yeah. Any questions on that? All right. Was it 2x squared plus 3x minus 7? Which I could just like, well, I guess I could have typed it up and dragged it around where I needed, but that's fine, I'll just rewrite it. What if I wanted to find f of negative x?
Distribute the negative?
What do you mean by distribute?
Like, just going down the line.
Maybe thinking about the next one I'm gonna do. But in this one, whatever you put inside those parentheses, that's gonna go where the variable is, right? So I put a negative x for x, it's gonna have a negative x there and a negative x there. So we're gonna have 2 times negative x squared plus 3 times negative x minus 7. Whatever you put in those parentheses, that's what goes in. And so we could evaluate it some. You remember if we square a negative x, we could write that as what? If I remember? Like when we were doing symmetry. No, a negative times a negative is just going to be positive, right? So if I square a negative 2, it's going to be positive 4, same as just 2 squared. So I can rewrite this as 2x squared. So if it's to an even power, you get rid of the negative, basically. Not so lucky here. 3 times negative x, that is going to be negative 3x, and then we get the minus 7. So it does change up the function a little bit. It was 2x plus 3x minus 7. If you plug in a negative x, it's 2x squared minus 3x. Any questions on that? All right, what if want to know negative f of x.
Oh, then that's when you distribute.
Yeah, it's basically multiplying your function by -1. So we'll have -1 times 2x squared plus 3x minus 7. And that -1 is going to distribute to each term inside there. So this is going to be negative 2x squared minus 3x plus 7. Did that already. 2 more. Any questions on those? All right. Oh my God. I give me one more here. It was f of x is equal to 2x squared plus 3x minus 7. What if I wanted to find f of 4x? Whatever's in the parentheses, you do what with it? Plug it in. So we're going to take the 4x, plug it in from x. So it's going to be 2 times 4x squared plus 3 times 4x minus 7. And we can evaluate that a little bit. If we square the 4x, what is that going to be? Right now? Basically, you square the 4 and you square the x. So it's going to be 2 times 16x squared. 3 times 4x is going to be 12x and the minus 7. And then multiply the 2 times the 16 and get 32x squared plus 12x minus 7. Any questions on that? And the last one, do I have room for it? Oh, I got tons of room. Okay, cool. So original function. If you're going on the calculus, this is something you need to understand for sure. F of x is equal to 2x squared plus 3x minus 7. What if I want to know what f of x plus h is? We're going to plug it in, right? So it's going to be 2 times x plus h squared plus 3 times x plus h. And then minus 7. Sorry, I didn't say it. The only difficult part with this I find is, okay, we can distribute the 3. That's not a big deal. It's going to be 3x plus 3h. But we also need to take the x plus h and square it, similar to what we did with the x plus 1 earlier, right? So I usually say, hey, let's work that out on the side. X plus h squared as x plus h times x plus h, which is going to equal what? You got the x times the x. That's not bad. Get x squared. X times the h. That'd be hx. H times the x. Let's say xh. And h times h, which is h squared. Any questions on that? We're going to clean it up a little bit, but just want to make sure everybody's with me at this point. Are there any like terms I can combine there? How come I can combine those? They're in different order.
It's still the same.
It's still the same, right? 2 times 3 is 6. 3 times 2 is 6. So the order doesn't matter in multiplication. So this is the same thing as x squared plus xh plus xh plus h squared, which is going to be x squared plus 2xh plus h squared. I like writing my x's before my h's. It really doesn't matter. That's totally up to you. It's just how I've always done it. Any questions on that? So be careful when you do it. Y'all shouldn't see anything above a square, I don't think. If you get a little farther in math, you probably start seeing cubes and stuff, but with this type of stuff going on. But if you do see a cube, you just do it again. Just multiply the square and then multiply it again by x plus h. All right. Because do you use FOIL when you do it?
I do the box.
So you multiply x times x, x times h times x, and then the last one is what? H times h.
Oh.
Yeah, so that's gonna be h. Any other questions on that? All right, so now we're gonna take that, plug it in for that. So switch back to blue. We're gonna have 2 times x squared plus 2xh plus h squared. And those all that's in parentheses, right? Because it's 2 times all of that. Let's distribute the 3 while we're here. So it's going to be 3x plus 3h minus 7. And then the last thing we need to do is distribute the 2. Don't forget to distribute it to that middle term. That's where everybody messes up, in my experience. So we'll have 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 7. We look to see if there's any like terms. There are not. That's that. It's not the prettiest thing in the world, but if you do get to calculus, whenever you do these, a bunch of reduction happens. But yeah. Any questions on that? I feel like that's the toughest one. That's why I spent a lot of time on it. All right. So, anybody still copying anything? Got it? Have one for y'all to try. So 3 first. I think we know there. We're going to plug in a 3 for our x's. Make sure you do it for all of them. And we're going to get what? 18 minus 9. So you got 9? Yeah. For the next one, we're going to do f of x plus f of 3. Now, we already figured out what f of 3 is. Figured out it's 9. So this is the same thing as just f of x plus 9. Right? Because we already figured out what it is. And so this is just going to be 2x squared minus 3x plus 9. Well, that's going to be. If you worked it out and did 2x squared minus 3x plus the 2 times 3 squared minus 3 times 3, you still get the same thing. You should at least. It'll work. It'll evaluate out. And so we're able to do that just because we know that f of 3 is 9 already. If you didn't know what f of 3 was, then you would need to work it out. Any questions on that one? That's like the only new one. All right, what was the next one? 3 times f of x. So that's going to be 3 times 2x squared minus 3x. We're just going to distribute that 3, so we'll have 6x squared minus 9x. Any questions on that one? All right, what was next? F of negative x. I like these because we're going to be using this actually in the next section. So this would be 2 times negative x squared minus 3 times negative x. If we have that negative variable squared, we can just rewrite it as 2x squared, and then 3 times the negative x plus 3x. That would be your answer there. Any questions on that? Then E, we're also going to be using that one in the next section. You have negative f of x. That's just like a negative outside or multiplied times a function. I like thinking of it as a -1 times it, but hey, whatever works for you. That's going to distribute to 2x squared. It's going to distribute to 3x, and so we're going to end up with negative 2x squared plus 3x. You just change the sign on every term. Any questions on that one? Oh, I left the x plus h behind. Yeah, forgot to add it. All right, what was next? F of 3x. So we're just going to substitute in a 3x everywhere else is an x. So we have 2 times 3x squared minus 3 times 3x, which we can square to 3x. The first one, that's going to be 9x squared. Oops. And it's going to be minus 9x. And then let's multiply the 2. So 18x squared minus 9x. Any questions on that one? All right, f of x plus 3. Things get a little difficult here. We're going to put an x plus 3 for all our x's. So it's going to be 2 times x plus 3 squared minus 3 times x plus 3. Which we can square the x plus 3. And that's going to be what? 2 times x squared plus 6x plus 9. And let's distribute the negative 3 to the x. So that'd be negative 3x and the negative 3 to the 3, which would be negative 9. Oops, let me get a parenthesis. I can see that being an issue, not distributing a negative, not getting the negative 9 there. So pay attention to that. And then finally, we're going to distribute the 2 for everything in those parentheses, and we'll have 2x squared plus 12x plus 18 minus 3x minus 9. And we can combine our x terms and our constants. So we'll have 2x squared plus 9x plus 9. Any questions on that? Oh, okay. That was a little tough. And lastly, f of x. Oh, sorry. Clean that up. F of x plus h. So that's going to be 2 times x plus h squared minus 3 times x plus h. And so that's going to end up being 2 times x squared plus 2xh plus h squared minus 3x minus 3h. And once we distribute the 2 to all those terms, we're going to have 2x squared plus 4xh plus 2h squared minus 3x minus 3h. And that is that. Any questions on f of x plus h? Cool. So if you understand that, that's good, especially the negative f of x and the f of negative x. We're going to be using that tomorrow. So make sure you understand that. All right. Now to something we're actually familiar with, hopefully. We're going to be finding the domain of a function. Now, I spent a lot of time talking about the domain of a variable, the domain of an expression at the beginning of the semester. Same things apply here for a function. It's just that they're written up differently. That's really the only thing. So you got to start off with the set of all real numbers. It can be whatever it wants. Then if it has an x or whatever variable you're dealing with, a variable in the denominator, you need to remove values that make the denominator 0. If it has an even root, you need to make sure whatever's in that even root is greater than or equal to 0. Okay? So it's the same thing we used before, just now we're talking about functions. So if we look at this first one here, I'll write it out. We got f of x is equal to x squared plus 5x. We want to find a domain. We want to find the domain of f. I remember I said I was going to write it like that. We're going to start. It could be whatever. It could be all the real numbers, negative infinity to positive infinity. Is there, our variable is x, is there an x in the denominator? We don't have one. It's basically an understood denominator 1 there, right? But there's no x in it. So we don't have to worry about that. Is there an x under an even root? That's an even exponent, but not a root, not a radical. I'm talking about a radical like this. There's no x's in there, right? So there's no restrictions on this. The domain of that function can be negative infinity to positive infinity, all real numbers. Any questions on that? That was 8. Huh? Yeah. Let's do B. G of x is 3x divided by x squared minus 4. Once again, we're going to start. Be whatever it wants. Negative infinity, positive infinity, no restrictions. Is there an x in the denominator? Yes. So we want to make sure that we get rid of the values that'll make that 0. So we're going to say, well, x squared minus 4 not equal 0. And we're going to solve it for x to see what we need to take away. So I like to do square root method here, just because I like the square root method. It's easy. So we got x squared cannot equal 4. Take the square root. Remember, it's going to be plus or minus on the side opposite the variable. We have x cannot equal plus or minus 2. Any questions on figuring that out, finding that? Now, we got 2 restrictions. Let's look back at it. Is there a variable under an even root? No, there's no roots going on in that. So the only restrictions we're going to have is going to be this. Now we need to write that in interval notation. So basically what we're doing is we're saying that we got negative 2 here, 2 here. Our function can have x values from anywhere but those 2 values, right? So I'll put parentheses like that, right? It could be to the left of negative 2. It could be to the right of 2, but it can also be in between. So we're going to have to write our domain as, oops, so the paintbrush. We're going to write our domain as 3 intervals union together. We're going to have that first interval. That's going to be negative infinity to negative 2. Then we're going to union it. We're going to have that middle interval, which is negative 2, positive 2. Right? All the numbers between negative 2 and positive 2, just not negative 2 or positive 2. And then union that last interval, which is 2 to positive infinity. No brackets on anything, because if I put brackets on the negative 2 or positive 2, it would include them. I don't want them included. Any questions on that? Good? Looks like we're good. Follow up. What if my function, let's call it a different name. I believe it was like 3x up the top, but whatever. What if it was this? 3x divided by x squared plus 4. What do you think you do? We'll do the same thing. All right, cool. Let's do it. So we have x squared plus 4 and I equals 0. That's the expression we have in the denominator. Try to solve it up. I have room? Yeah, I'll work it out. So x squared cannot equal negative 4. Now, when I take the square root on both sides, what I get is that x cannot equal plus or minus the square root of negative 4. Can I take the square root of negative 4? No, it's going to be an imaginary number. We're only dealing with real numbers in this class. So that means that x squared plus 4 equaling 0 has no solution. So there's no number that I can put in that denominator that would make it 0. So what do you think my domain of h is going to be? Am I going to have to take anything away from it? What do you think? There's no value that will make that denominator 0. The only value that will is an imaginary number. You're like, what? 2i, plus or minus 2i. But we don't care about that. So it's just going to be negative infinity to positive infinity. Because there's nothing that we need to restrict from it. So if you try to solve it to see what will make it 0 and you get no solution for that, that means you have nothing to restrict it. You have no restriction to give it from that. Any questions on that one? Because that's when it confuses people, that's why I want to do it. So you'll see it probably in the homework. What do you mean? Yeah. If you find like there's nothing that'll make it 0 in the denominator, then yeah, there's gonna be no restrictions. Same thing with the even root. If you find there's nothing, yeah, that's possible. If you find there's nothing that'll make it negative, it's gonna be positive, negative infinity to positive infinity already. So they use h, but they use t, so that's fine. They do h of t is equal to the square root of 4 minus 3t. And so we want to find the domain of that. So here, we start negative infinity to positive infinity. There's no variable in the denominator, but there is an even root. And so we want the stuff, the algebraic expression inside the even root to be greater than or equal to 0. So we're going to say, well, 4 minus 3t is greater than or equal to 0. And we're going to see what makes it so, and that's what our restriction is gonna be. So, got a few options here if you want to solve it. I like to add 3t to both sides. So let's do 4 is greater than or equal to 3t divided by 3. And so you have 4/3 is greater than or equal to t, which means that t is less than or equal to 4/3. All right, I just flipped the inequality around. I didn't change the sign, I flipped the sides. Any questions on that? So if I want to write my domain now, domain of h, if t is less than or equal to 4/3, that means it's going to be negative infinity to 4/3, put a bracket on that 4/3. Because it can be equal to it, right? Any questions on that? How am I doing on time? Yeah, I got time. I got 2 more. I got enough time. What's this? Oh, there we go. What if, let's call it, I don't know, d of t. What if it was 1 over the square root of 4 minus 3t? We would do the same thing because it's under the square root, right? But there's one caveat to it. Another one, we want to make sure that 4 minus 3t is greater than or equal to 0. But in this case, what do we want to take away from that? What do you think? It's in the denominator, right? So I want it to what? I want it to be greater than or equal to 0, but not equal. I want it just to be greater than. Because if it's equal to 0, I'm going to divide by 0. So if your root is in the denominator, you get rid of that 0 part. Now, if there's additional stuff other than the root, then you need to change it up and make sure the whole denominator doesn't equal 0. But since it's just the root in our denominator, we could just take away the 0, the equal to 0 part, and work it out from there. So let's go the other route. Let's subtract 4 from both sides here. And then we'll divide by -3, which is going to swap my inequality. And so I'm going to have t is less than 4/3, which means my domain, I should have called this d, but there you go, is going to be negative infinity to 4/3, but it will not include 4/3. Any questions on that one? I didn't realize I switched my watch. Got it? And one more. It's kind of the capstone. So we have f of x is equal to square root of 3x plus 12 divided by x minus 5. We're going to do the same exact thing we've been doing. We're going to assume it could be anything, but then we're going to look for our restrictions. So the first thing I see is we have an x in the denominator. We also have an x under even root. So we're going to look at both of those the root is not in the denominator, so I can't do like what we just did, just taking away to equal 0. So now I need to focus on both of them separately. So I know I want x minus 5 to not equal 0. I add 5 to both sides to solve that up, and I get x to not equal 5. So that's one restriction I have on my domain. X can't equal 5. Keep that in my head. Next, let's look at the root. We got the square root of 3x plus 12. So I know that 3x plus 12 needs to be greater than or equal to 0. Let's subtract 12. Get 3x is greater than or equal to negative 12. Divide by positive 3. And I get x is greater than or equal to negative 4. Oh. There we go. Nope, still not doing it. There it goes. That's another restriction. Now, when you have two restrictions like this, it's a good idea to graph them before you write your last interval. Just think about them on a number line. Got negative 4 here, 0 somewhere around there, and 5 here, right? The numbers I'm worried about. We know that it can't equal 5. So I gotta take that away. So no, can't be 5. It's greater than or equal to negative 4. That means it could be equal to negative 4. And it's everything that's greater than it. Oh, it hit a stop right there. But then I could keep going after I pass up 5. So how many intervals do I end up with? It looks like it's going to be 2. Right? I have the one from negative 4 to 5, and then from 5 on to infinity. So my domain of my function is going to be bracket negative 4 to 5 union. I got to make a little room here. 5 to infinity. Any questions on that? No? Got it? An interesting thing is, what if we got that x cannot be negative 5? It wouldn't have mattered, right? Because negative 5 is over here. We were always saying that x had to be greater than negative 4. So if one of your restrictions takes away one of the whole other ones, you just don't have to worry about it. So it is a possible thing that could happen. If this would have been x plus 5 in the denominator, you would just have from negative 4 to infinity. Because the negative 5 was outside of that reach anyways. So that's one of the things that can happen.